Hello, in this video I'm going to look at the effects of horizontal changes to the graph y equals tangent x. And the horizontal changes come from the b in front of the x and the c. All of this is part of the input to tangent, so that's going to have a horizontal effect. Now, I just want to again kind of go over the basic shape of y equals tangent x. And remember, the x here, it's not horizontal movement, it's actually rotational movement around the unit circle. Of course, when you go to graph it, you can see it as x. Then if you pop open the unit circle and lay it out, you can look at it as horizontal distance at that point. But it's just a placeholder for an angle, right? That's really what we're talking about. So the input's an angle, the output is a ratio. In this case, it's the ratio y over x, and you're using the coordinates x and y at that particular angle. That's the input. So if you remember, I use certain anchor points for the basic shape. Your basic shape basically looks like this, right? And so I use negative pi over 4, and then 0. So negative pi over 4, 0, pi over 4. And here's your coordinates, right? So then you're taking y over x, y over x, y over x, right? So then you get the tangent of negative pi over 4 is negative 1. The tangent of pi over 4 is 1. And the tangent of 0 is 0 over 1, or 0. So the tangent of 0 is also 0. So that's how it looks on the graph, right? Here's your points. And then the asymptotes, because you have a variable in the denominator, if that variable is 0, then it gives rise to an asymptote. So where is it that x is 0 on the unit circle? Well, you can tell it's here. So it's at pi over 2 and negative pi over 2. So there's your asymptotes. So just having that as a review, this is what you would have committed to memory, is this basic shape, right? And what I call anchor values, right? The asymptote values, and then negative pi over 4, 0, and pi over 4. Now, so what happens then is, what I want to do, if it's a complicated, input, what I do is I actually solve for the input, and I want it to act like the anchor values that I use. So I want it to act like negative pi, x equal negative pi over 2, x equal negative pi over 4, x equals 0, x equals pi over 4, x equals pi over 2. So I'm going to set whatever's in here, right, whatever's the input to tangent, I'm going to set it equal to those values and figure out what x will make it behave that way. So here's our first example, and it's not particularly complicated, but I'm going through the process so you can see I'm setting whatever's in the input, right, or the argument, equal to those anchor values that I want. And then I solve for them. So that means that when I put in this value here, negative pi over 2, in here, it's going to end up acting or taking the tangent of the anchor value I want, negative pi over 2. And I'll go through one of the more complicated ones a little bit later so you can see that. But if you just plug in negative pi over 2 in here, you'll see that you'll end up taking the tangent of negative pi over 2, which is where the asymptote would be, and so on and so forth. So here, what I would do then is, once I have these, I would say, okay, here's my asymptote, and here's another asymptote, right? And, oh, this should be a positive pi over 2. My apologies. I'm not sure why that came out to be negative. It's positive. Thank you. All right, so there's my asymptotes. And then I know that at 3 pi over 4, right, then what I have here is at 3 pi over 4, it's as if I'm taking the tangent of negative pi over 4 when I put it in here. And I know that the tangent of negative pi over 4 will end up being negative 1. So I'm going to just go over 3 pi over 4 and then down here to negative 1. And then when I put in pi, it's going to act like tangent is 0, which is 0. So I'm going to have a point here. So I'm going to have pi 0. And then when I put in 5 pi over 4 in here, it's going to act like tangent of pi over 4, which I know tangent of pi over 4 is 1 because I've committed to memory these values, right? So at pi over 4, tangent ends up being 1. So therefore, I'm going to go over to here, 5 pi over 4, and I'm going to go up to 1. So I'm going to go up here and 1. And now I'm going to go ahead and draw the tangent right there. Okay. Now I just want to address something here. you could draw these where you find the asymptotes and then you're saying that, well, every quarter of the way something's happening because here's 1 quarter, 2 quarter, 3 quarter, 4 quarters. You could do that, which is kind of what we did with sine and cosine. There's a reason I'm not doing that, and that is because this method of, this is just a different technique, so it exposes you to a different technique. You could use the old techniques. But what's happening is when you know what anchor values you want, you can solve for the x values that make that happen. For secant and cosecant, you're not going to have things happening a fourth of the way. So that's why I want to give you a technique where you can solve for what you want. Okay. So now I think that's this one. Let's go through another example. Here we have an effect where you have a bx. So again, if you can write it the long way. But the process is still the same. When you have a horizontal change, I like the technique of setting whatever's in the input equal to the anchor values that I want. And I, again, get those from the basic shape that I want, that I know. And then I solve for the x value that'll make that happen. So when I put in negative pi over 4 in here, I'll end up taking the tangent of negative pi over 2. And when I put in negative pi over 8 in here, I'll end up taking the tangent of negative pi over 4. So that's really what I'm looking for in terms of behavior. So now let's start putting this in. So I'm going to have, let's see here. First, I'm going to have at negative pi over 4, I'm going to have an asymptote. And then at pi over 4, I'm going to have an asymptote. Okay. And then I know that at negative pi over 8, it's going to behave as if it's, whoop, I got my cat here helping us out. Let me get him out of the way. Oops. Oh, no, sorry, baby. All right, so then when I put in negative pi over 8, it's going to act like tangent of negative pi over 4, which is, I know, negative 1. Tangent of negative pi over 4 is negative 1. So I'm going to have the point negative pi over 8 and negative 1 over here. And then when I put in 0, let's make sure you guys can see this. Yes. All right, when I put in 0, I'm going to be taking the tangent of 0. All right, so I know the tangent of 0 is 0. And then when I put in pi over 8, I'm going to end up taking the tangent of pi over 4, which I know is 1. So I'm going to have this pi over 8. It's going to be 1. And so I'm going to have a very narrow. Now, basically what I have is I have a tangent that looks a lot like my basic shape, of course, because it is the tangent graph. But it's more narrow, and that's because what's happening is when I put an input, I'm doubling the impact of that input. So I only need half as much as I did before. So therefore, I don't have to go out as far. I only have to go out half as much as far, and then I'll have the same effect, if you will. All right. All right, so thank you so much for listening.